So I guess, like Sir said, I'll go ahead and kind of get started by introducing myself. Hi, my name is Reid Vandewiele, or I guess that's a bit of Belgian name. I was correcting the pronunciation earlier, but I can't remember what it was. And I work for Puppet Labs. This presentation is also kind of a more technical session, sort of like the one just before it. So apologies again for not having sort of the grand idea overview before this got started, but I think it'll still work out pretty well. So I'm going to jump in. About myself. I work for Puppet Labs. I work in pre-sales engineering, which is basically kind of like professional services, except I don't have to worry so much about. I get to play with the toys, but I don't have to worry about what happens with them after I'm done. So, what's the plan for this this presentation? First off, introduction, bias disclosure. That was most about Puppet Labs. I'll talk more about that in a second. The title of the presentation was, if I go back again, it was DevOps and Successful Continuous Delivery. And so I'm going to be focusing on, first I'm going to talk about what DevOps is. I'm pretty sure everybody in the industry is more or less familiar with it. It's been a buzzword for the last couple of years now. But I can introduce that, talking about a survey put together by Puppet Labs in 2013, sort of about the current state of DevOps. I'm going to be jumping after that into DevOps is about the intersection of the operations team and the development team, which traditionally in years past have been sort of siloed and separate. So I'm going to talk about the old approach to IT automation. What it's traditionally looked like. Then I introduce configuration as code, which is sort of the basis for the Puppet product. It's a IT automation product in that space, and this is kind of how it works. New approach to IT automation, which is going to be wrapping those together and actually using, showing Puppet how it fits into an automated continuous deployment workflow. And finally, talking about everything that we just talked about. So first off, Puppet Labs. It was founded in 2005, so we've been around for quite a few years. At that time, it was primarily an open source company based around services. Today, it has upwards of 20,000 users. Some of our largest deployments have 50,000 plus nodes, all being managed by Puppet. 6,000 plus active community members, and quite a few downloads. This slide is actually a little bit out of date. It was from, I think, September of last year, when most of these numbers were calculated. We've grown pretty significantly since then. So that's what we do, and this is the bias disclosure. I work for us. I work for Puppet Labs. So specifically, I mentioned I'll be talking about DevOps, but mostly the context I'll be using is the Puppet product specifically. So there are other tools that enable the same kinds of things I'll be talking about, but I'm not nearly as familiar with them as I am with Puppet. All right, so jumping straight then into kind of what is the overall presentation objective. And we talk about DevOps, talk about what is it? How does it? Not so much about where it came from, but more just about what is the current state. Introduce configuration as code, which I already mentioned. And sort of how Puppet or a tool like it fits into a workflow like Jenkins, where the objective is you have your applications, your code. You want to, as you iterate on them, automatically push them into production. Okay. So IT management. Puppet, fundamentally, as a product, is really all about the IT team, the ops team, the people in charge of putting together the servers and deploying the application. So their needs or challenges are productivity and efficiency. They want to be able to deploy applications quickly. They want to manage them successfully. Configuration drift. So the environments they deploy should be stable. They should be predictable. They should be what is expected. You shouldn't have to worry about one server being different from the next if it's assigned to the same role. Responding to business needs, that's again just really it's all tying together the same thing. You really want to be able to push changes, applications, configurations efficiently, quickly, all that kind of fun stuff. So I'm going to jump straight into DevOps. In 2013, Puppet Labs, this is kind of going to introduce the concept or topic, as it were. Put together a report. We did a survey in December of 2012, basically asking people from all kinds of organizations, all levels of organizations, management, engineers, operations team, development team, what kinds of DevOps practices were being used in their organizations, how long they've been being used, what the effects were if things were changed. And this is a follow-on to an earlier survey done in 2011, so we also have some information about sort of the change between 2011 and 2013. So first off, just some definitions in case anybody's unfamiliar. What is DevOps? I pulled a couple of different quotes. First off, just some from the web. Wikipedia currently the definition is, software development method that stresses communication, collaboration, and integration between software developers and information technology professionals. Okay, another one, system administrators participating in agile development alongside developers and using many of their same agile techniques for their systems work. Okay, we're going to boil that down and say that for today, the working definition is collaboration between development and operations teams to achieve a common business goal. The results of the survey were relatively, the main thing first off, between 2011 and 2013, the prevalence of DevOps practices in IT organizations grew pretty significantly by about 26%. In 2011, about 50% of the individuals surveyed responded that they were using DevOps practices in their organizations. In 2012-13, 63%. So DevOps is on the rise. It isn't, when it first came out, I personally actually thought it was something of a buzzword. Yes, it was a valid cultural practice, but I was somewhat concerned over the number of times it was uttered in conversation. But it appears to have caught on. It actually means something today, which is good. Other results. Real quick, of the organizations that responded, they were kind of categorized into a couple of different things. Most important one was high-performing organizations. High-performing organizations tended to ship code 30 times more frequently than low-performing organizations, with change lead times of very, very small, just a few minutes. And they experienced, 50% fewer failures, and they recovered much more quickly than the other organizations. Okay, so this is a high-performing organization. To tie that back in, we also found that organizations that had implemented DevOps practices, which again is communication and collaboration between development team and operations team, and also agile practices being used by the operations team. Organizations with those DevOps practices are up to five times more likely to be high performing, which again, 30 times deploying shipping code 30 times more frequently with 50% fewer failures. Okay. So two practices that really stood out in the high performing organizations were they were using version control for their infrastructure management. So this is separate from the applications themselves. Applications have always been in version, well, hopefully always been in version control. But infrastructure itself has less of a history of that. And automation. 82% of them were using automated means of deploying their code. Okay, so just a checkpoint. You know who I am. We just talked about DevOps. We're going to move on now to, we said, what is the key practice here? Keeping their infrastructure in version control and using automation for deployments. Let's talk about that by starting at the very beginning before any of that. So, bold approach to IT automation. Traditionally, oh, I'm sorry, I hadn't realized that was a GIF. It didn't show up that way in PowerPoint. Manual configuration, is the beginning. Back when you had, pet servers with, personal names. Administrators would go out to each server individually and set it up and get ready to go, and then pass it off to the development team or what have you for deploy the application, etc. Obviously, that doesn't scale. A single administrator only has so much time, can only do so much. So we have other methods of kind of building that out, making it making it possible for a single admin to do more things. And that was two things. First off, custom one-off scripts. So individual organizations would write, or individuals inside IT operations would write their own scripts. It would be an automation. It would SSH in a for loop. It would perform the necessary work of deploying an application or configuring a server across as many as they needed. But these tended to be one-offs. They tended to be organization specific. The individual who wrote them tended to be their owner, and usually, especially if it was in I don't know, kind of a Perl shell script combination. That's my greatest fear. They're not maintainable. They're not known. They're not there's no community development and that kind of stuff. Okay, so you can use that to push automation now. So golden images. That's sort of the next step up. We've done the manual configuration, we've used the scripts, we've produced a result. Let's go ahead and save that, snapshot it, make it so we can get back to that point exactly. That's great, except at that point, that's okay. Let's say you have, if you only have one kind of server that you deploy, you're highly unusual. So we only have one golden image. Usually the need for golden images tends to bloom. It tends to get really big. One image is not enough. It's going to be one image for each version of the application, one image for each role. It blossoms into a very difficult to manage number of systems. Traditional configuration software tends to be large, expensive, and difficult to use. Use proprietary database backends. Not really the kind of thing that we're looking for. Okay, so that's sort of the basic history of IT automation. More recent approaches, I'm going to focus on this concept. We're going to call configuration as code. We say rather than working on artifacts, golden images, rather than working on custom one-off scripts, which are procedural, do this, do this, do this, do this, or any configuration, let's actually use software to define what our infrastructure should look like. So defining infrastructure in code or in software changes everything. And this is kind of bringing those agile development processes into IT. So configuration as code. Let's use this as an example. This is Puppet-specific code, but a lot of other platforms use the same kind of thing. And the idea is we have a plain text file, which has a very simple structure. It says, in this case, this is a Puppet example describing a file. It says a file, specifically at C2doers, should be a file. It should be owned by root. The group should be root, and this should be the mode. It's a text description. Okay. So what can you do with this? It's plain text. You can stick in revision control. At this point, it becomes code. You can use the same kinds of practices on this content that you use in software development. You can create effectively builds or versions of all the code that defines a system. You can say, okay, this is one snapshot, one version. Let's make the changes, iterate, commit those changes. We have the next version. This is another example. The file was very simple. This is a description of a user in the Puppet configuration language. And I'm going to jump into Puppet specifically in a little bit, but for now, we're just kind of walking through the slides. It's designed as configuration as opposed to code. We're not saying do this, do this, do this. We're saying this is how things should be. This is a user. And we have other abstractions. We're not saying run this command so much. This is the thing we should have a PostgreSQL database, a database grant, or a firewall rule should exist and have these properties, these parameters. So you can tie all of these things together, and say in code maybe something like here's an abstraction called SSH. We want to make sure that the package OpenSSH is installed. The configuration file should be a particular way. The service should be running, and this piece of description is a single unit. So actually, before I go on, I realized I jumped straight into the configuration, the Puppet kind of stuff, and I started showing you Puppet-specific things. But just out of curiosity, how many people are currently familiar with and/or use Puppet specifically? Okay, so a fair number, but there's also a lot of people who are new to it. So later on we're going to be using just some basic examples of what Puppet actually looks like in production. So hopefully we'll get into what all this does and how it works and how it's used. Okay. And kind of at the top level, just to tie those basic code examples together, you can end up saying, I'm going to describe what one of my servers looks like. I have an application server here, and it should include my SSH as I described it, and it should include my app. Maybe here's a web front end. It should include SSH. It should also be running Apache and have the front end profile, whatever that entails. So all of this code, which I haven't shown you the structure, but I've just shown you snippets and bits and pieces, but all of that gets put into a revision control system. Subversion, Git, perforce, what have you. The main thing here is that by doing this, I said earlier, configuration as code changes everything. Suddenly you're using the same practices which are well refined in the development world for keeping track of your infrastructure. So the platforms on which your applications are deployed are now defined and maintained in the same way that the applications themselves are. So, and what does this give you? It gives you the ability, if you have basically the definition of your platform, in addition to your application, you have the ability to reproduce it. You're building your platform based on this code. And I'll jump to actually showing the code in action, I promise. You have accountability. All of this definition is in revision control. So previously, where you would have a server or server farm out, in production or in the tested or QA environments, someone would go and make a change. There's not necessarily a good way to keep track of that. People have, various practices, and sudo's a good way of having logs with it. This way, everything's in revision control, and you can see who made the change when and why, which is important. You have I don't think you wrote it here, but visibility is part of accountability. You know why a change was made. That's all in the revision control log. Testability. We'll get to this. It's probably the most relevant part of this presentation since we're focusing specifically on continuous deployment and automation. Okay. So, talked about configuration as code conceptually. Next, I'm going to talk about new approach to IT automation. This is where we actually get into, okay, I mentioned configuration as code, but how do I actually use that? What does that mean? And that's going to be broken out into sort of a slightly larger block. I'm going to introduce Puppet Enterprise, which is the specific product that I'm familiar with. I'll demonstrate it particularly. There are others, but this is the one we'll be talking about today. I'm going to talk about a DevOps workflow with Puppet. That's going to tie pretty directly into the Jenkins presentation we had just prior to this. Jenkins is kind of the orchestration layer. It's the define the build, define the jobs, the pipeline, if you will. Puppet is a component, or configuration management is a component in that pipeline. The idea is to have your automation not only deploy code to environments, but be able to deploy those environments themselves and define exactly how they're built, what they look like, and maintain that. And finally, automation. That's kind of the automation integration. And we also have steps. What about after deployment, after testing? Hooks into that we'll be talking about. Okay. So Puppet Enterprise. Fundamentally, what Puppet Enterprise is a configuration management tool. The basic premise is it gives you the ability, it includes a domain-specific language, which is some of the code example we've seen so far, and we'll dive into that specifically more, to define what it is that you want your infrastructure to look like. It lets you do things like say, I want all of my servers to have this particular security policy applied. The security policy looks like a set of syscontrol values, a set of SSH authorized keys, packages that should be installed, packages that shouldn't be installed. It's effectively a policy. So the DSL allows you to define a policy that your server should all adhere to. After you've written that policy in the DSL, the domain-specific language, Puppet as a utility basically implements it on systems for you. That includes AIX, Windows, Solaris, Linux. It abstracts away the underlying differences in operating systems. So you might describe a user should be deployed on this system. You don't have to worry about whether you run the user add utility out of the etc password file directly. If it's on Windows, if you go into the control panel and set up the user manually, that's abstract. It's platform independent. So the text description is Puppet Enterprise is IT automation software that helps system administrators manage infrastructure throughout its lifecycle, from provisioning and configuration to patch management and compliance. And there's a little bit of a marketing spin on that one, but we're going to be looking at the core today. There's a lot of stuff that Puppet Enterprise does around provisioning specifically, but we're going to focus right now on configuration and that DSL that I mentioned earlier. Okay, so how does Puppet work specifically? Before we can jump into the automation and workflow, we have to know how this piece kind of performs and functions. Puppet allows you to define, as I said, the desired state of the infrastructure and the configuration using a declarative language. Declarative is the kind of key word here. Rather than writing a script where you say, do this, do this, do this, you're declaring what it is that you want. I want to have these users. I want to have these applications. The configuration should be just so. So once you have that, the next step is Puppet as a utility will basically simulate the configuration change on your system. You can say to Puppet, here's a manifest. The manifest refers to any file with Puppet configuration code in it that I've written describing a state. Compare it to the system and see if there are any changes, see if there's any discrepancies, see if the two are synchronized or if they're out of compliance, if you will. After simulating, you have the ability to actually enforce the desired state. And we'll see that in action. And finally, and we won't get into this much today at all since we're mostly focused on, actually we will, because reporting differences is kind of important for running tests and making sure things worked. We'll see that after you've done that, you have to report of all the state and changes that were made. So I'm going to jump back to this. We'll go into a demo just in a second. This is, again, an example of the DSL. This is what we call a resource. It's the most fundamental building block of the domain-specific language. Every resource will have the same basic structure. It's first going to have a type, which is the orange word user right up there. That's the thing that you're describing. Actual implemented configuration often includes changes to files, running commands to operate on the processes memory. But fundamentally, we're just going to talk about the abstraction in Puppet. And then after the type is the name, in this case Reid, and everything below that is a property or a parameter, some setting that describes an aspect of how the configuration should be. I say the user should exist. This is what its UID should be. Its shell should be, probably not that actually. But That's the concept. So let's go ahead and let's just demonstrate real quick what you actually do with this once you have it. I'm going to drop out here. So I'm going to copy this, this code here, this description. And I have a test environment available. Is that still showing? That is, that's good. Which I'm going to use to kind of show what happens. So this is a Linux system. I'm going to go ahead and take that file. You can call it user-read.pp, which is a Puppet manifest. I'm going to go ahead and paste that content in there. So now we have a description of a user. I'm going to save that in a file. Just a plain text file. I can cat that out. Nothing complicated here. Now that I have it, I can use Puppet to, the first step we described was, okay, let's simulate this. Let's compare the description I'm giving to the running system. So let's go Puppet, apply, the name of the file. I'm going to tack on a flag here called no-op, or no operation. This is the simulation mode. It's going to say, Puppet, run this file, but don't actually do anything. Okay, so we get a little bit of output. We're saying, Puppet has noticed that the user read doesn't exist. Currently, it's absent. It should be present. Hasn't done anything. I can run that again, and I'll get exactly the same output. The simulation is effectively a no-op. If I take off the no-op flag, Puppet is able to take, instead of just simulating the change, Puppet is able to actually apply it for me. It's going to say, you said that the user read should exist. It didn't previously, so I went ahead and created it. If I run it once more, it's going to do nothing. And the reason for that is it looked at the system, it saw that the user read was there, it looked at this description, it compared the two, checked the shell, checked the UID, all of that stuff. Saw they were the same and said, okay, there's nothing for me to do. This is an important part of configuration management software, an important property. It's called idempotence. Regardless of what the initial state of a system is, whenever you run the configuration software, the end result should be exactly the same. The result should be that the system then, at the end, matches the description you've given. It shouldn't break the system to run the configuration multiple times. You should always be able to take any system in any state and try and bring it into the compliant state that you have. Okay, so that's kind of a idempotence, a core tenet of configuration management software, and at least Puppet. Okay, so that's basic usage. So you can go ahead and jump back to the presentation here for a second. Okay, there we go. So we can write as many of these as we want. Once we have the description, what does Puppet look like in production? For that example, I just showed a very simple running Puppet on the command line. But Puppet is designed to run in a much bigger environment. It's designed to run in a kind of a traditional server-client kind of architecture. The idea being you have a central Puppet master, which contains all of the manifests, the code that you've written, and everything else in your agent or in your environment is an agent, or a node, a client system. The way the workflow works is periodically, the Puppet agent runs continuously on all of your agents for all of your clients. It periodically submits facts, which is information about the agents, requests a catalog, which is basically saying, tell me who I should be, and actually applies it locally. And you'll see all of this in the Puppet Enterprise console in a second. But, excuse me. I'm not going to get into this too much because really what we care about right now is the continuous deployment. So, the application lifecycle in DevOps. What we just demonstrated is that in Puppet Enterprise you have the ability to define in code what your infrastructure should look like. Okay, you can build a definition. It's in plain text. You can version it. Once you have that definition, Puppet Enterprise allows you to realize it on real systems. So what you can do is you can say, here's the infrastructure definition that's been written by my ops team, or written partially by my dev team. They describe what an application deployment should look like. I'm going to use that to deploy my dev environment. Okay, if that passes, if everything works, I'm going to take that same definition that I've written and go ahead and promote it to my QA environment. So now I can build my QA environment exactly the same way that my dev environment was built. See if it works, pass all the tests, all that kind of fun stuff. I can then stage it using the same infrastructure definition and finally push that infrastructure definition out to production. Basically, it's the same kind of workflow you have for your application code. So the same code that defines production can be used for local development environments. Even a developer's laptop. You can say, the developers themselves. This is sort of the DevOps, the communication between the development team and the operations team. You can say the developers, you're writing this application when it's deployed. Give me a piece of code that shows me what needs to happen, what needs to be the case. The idea here is you can eliminate the developer turns around and says, well, it works on my machine. Why didn't it work when you tried to deploy it? As long as all of the development environments are built using the same version code, that shouldn't be an issue. And there are utilities. There are differences between dev, QA, and staging. Mostly things like, what is the DNS name to use for the load balancer, the database backend, that sort of thing. All that can be abstracted. I'm not going to go into the details too much. But fundamentally, the same code can be used to deploy any environment. Okay, so let's talk a little bit about, now that we have this piece of code that can deploy an environment, which is basically the underlying platform for an application. What about, where does that fit into CI or CD? Puppet plus Jenkins. So Puppet is configuration as code. Okay. And I'll talk about testing. I'll just kind of briefly name some things real quick. But because Puppet is configuration as code, there's a full gamut of tests that can be run against that code. We have static analysis, checking the code for just basic validity before it even goes anywhere. All the way up through basically unit testing. We call it catalog testing, making sure that the compiled result is what we expect it to be. Integration acceptance, making sure that when it's actually deployed or run on systems, that the end result is what you want. Making sure that, for example, I expect that when I deploy Apache, I should have something listening on port 443. Those sorts of tests. And also changes to infrastructure are deployed just like applications. It's code. You make a change, you push it, goes through CI. It's pushed out the other side. Okay. And you can also then say, make dependency statements like my application has been tested and known to work on environment version A or environment version B, and so on and so forth. So I'm just going to highlight real quick. I mentioned automated testing. So manifests are the code that the administrator writes in Puppet that describes an infrastructure. So you can do testing at the manifest level and say, is this syntactically correct? Is it the case that when I trump that there are no conflicts? Puppet, I didn't put a slide on this unfortunately, but Puppet fundamentally what it ends up doing in the background after you've written all those descriptions is it builds an acyclic directed graph and says, you've said that this user should exist, it should be this way, but I know that I can't worry about the service until the user exists. So it builds a graph of all the dependencies. And it can check at this point whether or not that graph makes sense, whether there are conflicts, things that if you've defined in one place the user should have UID 1000, in another place the UID should be user 1001. That's going to be a conflict, and we'll tell you about that at this point. You can test for that. Finally, once you have manifests, you compile them into this artifact called a catalog. And the catalog is basically an assertion about what a system should look like. You can make tests on those assertions. You can say when you compile all this manifest code, the assertion should be that the Apache package should be installed. If that assertion doesn't check out, then something's wrong. So we can run tests against the catalog. Finally, acceptance testing is on the node. You can actually run in simulation mode. You can say, okay, I run this code on the node. I expect that this change should be made. I run this code on the node. I expect at the end that this condition should be true, that the port, we should have a process listing on port 443. And at the final, at the very end, you have all these reports generated. You can say, I expect that when Puppet is applied, no changes will be made after the second run, since everything is in compliance. Okay, so more direct integration, beyond just the ability to take your code, your infrastructure definition, and test that directly. Puppet has the ability to deploy, or model and deploy, Jenkins itself. So you can write up your testing infrastructure. You can say, this is what my testing infrastructure should look like. This Jenkins server, these jobs, all that kind of fun stuff. Other integrations that exist right now are, Puppet Jenkins can test and promote changes to infrastructure defined in Puppet code, same way it does application code, and stage and deploy infrastructure changes to different environments. Okay, so with that out of the way, let's kind of look at an example, kind of workflow chart for what that might look like. And this is a simplified chart. There's a lot of things that aren't going on here that could. But the basic idea is, well, in this case, we have our Git repository over there, the Git SVN repository. All of the application code, which in this case can actually include infrastructure definition, gets committed to the Git SVN repository, pushed to Jenkins, does its testing, does its syntax, static analysis, all that fun stuff. Potentially spins up new environments to test the code as part of the process. Or in this case, it's a simplified version, just pushes the RPM or the artifact, whatever that is, to the dev environment. In this example, I actually stole this from a slightly different presentation. So the RPM represents Puppet manifests code that's been written to define the infrastructure. That's literally being pushed out of servers as an RPM. It gets run, it gets tested. If it passes, it elevates to QA. Jenkins has more of a hand in this than is displayed here on the graph. Runs in QA. If it works, gets promoted to prod. This can be, an application or just Puppet code. It's kind of a simplified version, actually. So the end result of all of that, you have the ability to define your infrastructure and have a reliable environment produced at the end, and all in code. Okay, so that's not the end of the story, though. After the platform has been produced or laid down, Puppet also has the ability to tie into sort of next step applications like deployment automation apps. Any deployment automation app, most of the ones on the market don't necessarily worry too much about the platform. They're more focused on the workflow and the steps required to deploy apps. They're kind of an application level sort of thing. Puppet can provide an underlying platform for all of those, that produce reliable environments for them to work on. And it provides a lot of extension data APIs for integration with third-party applications. And I was going to mention specifically, Xebia, which you got to talk on. I guess Andrew was going to talk from Xebia. We can integrate with Deploy It, for example. Xebia actually publishes a Puppet module for integrated Puppet and Deploy It, which allows Puppet to, as it provisions a new environment, automatically manage either the Deploy It server or register new hosts as they come up with Deploy It. So you have, it's just automatically as part of your environment. Everything is pulled back to the center. This also works with things like stepping back for a second. Nagios is a simple example. Puppet has the ability, when you spin up a new host and you define an application, it can register that host in the Nagios server, so you have automatic monitoring. But that sort of integration is sort of the next step. Okay. So that was sort of the overview of what Puppet can do and what it looks like, kind of tying it into the the overall picture of the continuous integration, continuous deployment environment. The idea being, I guess I can probably just step over to the conclusion, or what I wanted to do is jump into Puppet Enterprise for a second. No, I think I'll go to the conclusion for now. The idea being, we described DevOps. What is it? It's basically taking the practices from agile practices from development, and also applying communication, making sure you have less of a silo, more communication between dev and ops team. We have infrastructure as code, so basically tying in kind of the final component for continuous deployment. You can continuously deploy your app onto a platform. It would be great if you can make it so you can continuously deploy your platform as well underneath the app as part of that pipeline. Testability, repeatability, and operations. We also integrate with Jenkins for continuous integration, build, so on and so forth. And all of that's enabled. Basically, I think the core practice is configuration as code. So, sort of next steps. I realize I have quite a bit of time for questions at this point, but next steps are for more information on this specifically, whether it's using Puppet Enterprise or DevOps in general. I mentioned we have the State of DevOps report. This is a survey. It has all the results. It also includes a lot of links to resources for learning more about DevOps, instigating DevOps practices in an environment, that sort of thing. And also for Puppet Enterprise, and I'll jump to that in just a second. Puppet Enterprise is free for up to 10 nodes if you'd like to try using that as a tool. It's available for download. Just go to puppetlabs.com. And what does that look like? I mentioned on the command line already, the configuration as code. I can define what a user looks like. I can define other things. I can define what a service looks like. At the end, what you end up with at this level is an environment where you have the ability to say for a particular node, I want to make you a Puppet console node or a Puppet master node. or an mcollective node. You can just assign classes once you've written them, get information back about the system, factor information, and so on. I'm not going to do a full demo on that, I think, because really the focus was DevOps and successful continuous delivery. So, any questions? I'm going to jump to that. I apologize for not quite filling up the entire time slot. But from what we just talked about, which is Puppet and continuous delivery code infrastructure as code, any questions you have for me at this point? Yes.
Where you have separate operations teams from your development teams, how do you got to work in those environments?
Okay, so the question is, when you have separate operations team from your development team, which is sort of a traditional situation, how do you get Puppet to work in those environments? Or the whole DevOps integration, which is the fundamental core concept of DevOps, right? In the case of something like Puppet or configuration as code, the first thing you get is, when you have configuration as code, we immediately get a reproducible and testable and more stable set of environments. And so if you can enable your developers to spin up their own test environments by giving them this code or this configuration, then you know that they always know they have a reliable, they know what they're deploying against. They're not running on their laptops anymore, they're not running on separate test environments. The test environments mirror production, that's the first gain. And that doesn't actually even necessarily even need that much facilitation and communication between the two teams. The next step after that, once you have the reliability of these environments, is to actually turn around and the operations teams can enable the developers and say, by the way, when you give us the artifacts, the deploy artifacts, if your application requires more configuration than dropping a WAR file or dropping a jar file, then we're going to enable you to actually define what that configuration is. You can write it in this code. You have access to the repository, or you can give us pieces that will integrate into the full repository. And when you give us the artifacts, you also have to tell us how it's deployed. And then you start kind of a review process at that point where the ops team says, no, you can't do it that way. You can't open this port. You have to have all these practices that need to be applied. But part of the handoff then becomes the actual deployment steps. And that's often kind of a big hurdle for significantly siloed teams. The artifact is thrown over the wall and nobody knows how to use it or what it requires to run. So that's kind of the next benefit there.
So that's sort of explaining how you go. Whether, I can think from the developer's perspective, it's actually quite a convincing argument. In an operations team where they control all this stuff and they don't feel as though they need to have somebody else telling them how to configure these servers, how do you convince them?
So that's the argument just stated was compelling from the comment was compelling from the developer standpoint, where they want to have more input into the deployment process. But from the ops standpoint, it's maybe culturally not the case. They want to maintain control. They don't want the developers to have that sort of access. What I've seen personally is usually, as long as the ops team has final say, most often the case is that they're okay with this. If they are, significant, they don't want the developers to have any say in the deployment of the application. It still works because we have the foundational step was the ops team gives the developer a test environment in the form of this code and says, this is what your app has to run on. And so that's still the core benefit. Yes?
I'm wondering about the testing side of configuration. So you mentioned using no-op to verify what it does do, but from an automated scenario, how would you gain confidence in the public scripts that you're pushing out will work?
Okay. So the question is more. So we mentioned, briefly mentioned the testing possibilities for this sort of setup. But how do you gain confidence, beyond the simulation mode, that the Puppet scripts or manifests that you write will actually work? So I'm going to use that. I think the best way to answer that is to talk more specifically about the kind of testing that's available and sort of what the results are. And if I can jump back a couple of slides to this one. I mentioned, first off, we've gotten to this point. We did a static analysis. Gotten to this point, we have a catalog. This is the piece that says what should be, but it hasn't actually happened yet. At this point, acceptance testing occurs on the actual node, where we take the catalog. The first step is to run in simulation mode, but okay, now what? The next step is to actually run in, usually what you want to have at this point is you'll spin up a new testing environment, or you'll have an existing testing environment. And after the simulation passes whatever checks you applied there, you actually apply the code. At the end of the application, you have two possibilities. The first one is this report right here. The report effectively has what's called an event. The report is pure data. It's just a JSON data structure that details for every item in the catalog. And the catalog contains things like it says, this file should have this content. This service should be in this state. The user should have these characteristics. For every item in the catalog, you're going to have a corresponding event in the report. That event is either going to say, at the end of the Puppet run, I needed to make these changes in order to bring it into this state, or no changes needed to be made, this was checked. Okay, so that's one thing, you have the report. So Puppet thinks it did the right thing. That's great. Beyond that, the next step is to actually perform independent testing of the result on the system. One specific utility that I've seen used is called, it's kind of a new one actually, it's called ServerSpec. And it's basically a testing language that allows you to say things like, we should have a process listing on port 443. We should have a package installed, and this is independent of Puppet. And all it does is it runs after the Puppet run is completed and checks all of these conditions. So it's not worried about how Puppet did it, it's just worried about what the end result is. So the testing steps, I'll actually just kind of detail this a little bit more. For the manifests, we have a simple parse checker, static analysis. And we also have a style checker. All of these are two both automated tools. For the catalog, we have something called rspec Puppet, which basically allows you to use the Ruby rspec library to perform unit tests against compiled artifacts produced by Puppet code. So that's unit testing right there. And then we have acceptance testing, which again is probably the server spec side, and also against the reports. Okay. Yes?
So one of the things that I've been struggling with handling secrets, like SSL certificate. Any advice on how to do that well?
Yeah, so the question is, what about secrets? We just said, I have this defined infrastructure that I'm then going to hand to all of my developers to run on their local laptops. But what if I have secrets like SSL certificates or passwords or any credential type or secret type of data that you don't want to include in that definition? So way back when people when Puppet first started in 2005, there wasn't really a way out of that. You had to somehow include that data. Since then, we've made a lot of different changes. I won't go into the history too much. The current way we do that is Puppet has the ability to ingest external data through a utility called Hyra. And basically what this allows you to do is in the Puppet code, whenever you'd be defining what a secret should look like, instead of saying my password is X, I would say my password is, and then give the lookup key to pass on to the Hyra utility. And what the Hyra utility does is anytime it's invoked, it says, okay, I've been invoked for a particular node. It looks up what it knows about the node. The node is in the development environment. Okay, I'm going to check and see if there's a particular value for this key available for the dev environment. So for example, is there an SSL certificate for the dev environment that I should be using? And it will pull that from an external source, whether it's a REST interface, a flat YAML file, whether it's a MySQL database. Effectively, what it lets you do, I'll just do a simple example here. So I have, user, let's say I didn't want to specify the password. I can give it whatever the key is, and the Hyra will perform the lookup from an external data source. This separates the code, the definition of what I want, from the pure data in the background. And you can configure Hyra from where to get its data, whether it's a plain YAML file or a REST endpoint. It's separation of code and data is the main point. There's a couple of blog posts on that too, which I can, if you're interested, contact me, get a hold of me after the talk or during one of the coffee sessions, and I can point it out. Yes?
Can third parties use Hyra? So, for example, you might deploy your Apache config with templates and stuff stored in Hyra. I might want to access some of that config from one of my applications. Can I do that?
Absolutely. Hyra has a command line utility out of the box, and there's also REST interfaces available for it. So regardless of what its backend data sources are, you can use it as sort of the single endpoint for retrieving the data. Yes?
Can you recommend a pattern for using Puppet with Jenkins and/or mcollective?
Okay, so mcollective, the question was, can you recommend a pattern for using Puppet with Jenkins and/or mcollective? So I'll define mcollective real quick. Puppet Enterprise is split into a couple of different components. We mentioned Puppet already and Hyra. mcollective is, I'll start this by saying Puppet is fundamentally continuous enforcement configuration management. You define a model, and Puppet will make sure that the model exists. This is continuous. It's not about events. It's not about flow. mcollective is an orchestration utility. It's effectively a message bus architecture. It's a pub sub sort of thing where all of the agents in your environment are listening on a bus and can receive, according to, you might be able to say, all of the Red Hat agents in my environment, please say hi. And they'll listen to the message, receive it, and based on their metadata, they say, I'm a Red Hat agent. I should respond to this message. And that can include either simple responses and information querying or also issuing of commands and directives. So patterns for integrating Puppet with mcollective and or Jenkins. And I assume this is specifically in the context of like continuous deployment or continuous integration. When the Puppet, so the first one, the simplest one, is we recommend that Puppet manifest should be kept in configuration management, their code. Mention that there are utilities available for static analysis and other checks against that code. Jenkins should be part of the process of deploying or staging, test against those, pushing those into production, or into test QA production. That's pretty simple. Jenkins also, you can use that to actually spin up new environments when code is pushed. If something passes the static analysis and passes the unit tests, you actually want to make sure it works. Jenkins jobs should include the ability to spin up new environments, deploy the code there, test it, you do the acceptance level testing, pull that back. So basically, exactly what we typically recommend and what Puppet Labs does internally for our own product releases is, in infrastructure, is use it in exactly the same way you would app deployment, use the test for Puppet code with the addition of spinning up environments. At that point, using the new Puppet code that you're testing to actually bring it up the rest of the way and make sure it works before pushing it out.
So that's to test your infrastructure, but if you want to test your app, the full stack, is that when you introduce it alongside?
Yeah, so if you want to, so that's the whole infrastructure. To repeat the question for the mic, that's the whole infrastructure. But what about the application? So that really depends on how the specifics depend on how your application is modeled, whether it's all modeled in Puppet or it's a complex deployment that you'd prefer to use an external utility for. If it's all modeled in Puppet, then that's part of your code. You define, in addition to the infrastructure, all of the components of your application that goes out with the test. If it's a larger application that you prefer a dedicated workflow utility for, Puppet, like I mentioned in one of the slides, has integrations with dedicated kind of deployment management utilities. And so Jenkins can actually, as part of the deployment, Puppet can set up the setting templates, or if you're using an existing one, it doesn't matter, you can register the new host with it. And then Jenkins can trigger the deployment and then test the results. Any other questions?
We can use the time for people to have a quick comfort break before we...
Okay, I'm sorry, I haven't been paying attention to time.
No, it's fine. It's good.
All right.
Two more.
Yes. Sure.
Well, I haven't used Puppet myself, but to me it looks like this kind of tool to describe your environment and your application. So part of this description makes sense to ops people and infrastructure to how the description looks like up to the point that it's complex. But some of it also is very relevant to application teams and development. Like, I want to have, I don't know, a firewall access to blah blah blah, or a web server capacity for my specific application. Now, does it make sense to have Puppet modules, or at least a bit that is specific for that application? We need actual application code base, so that's part of an application. Kind of closing the gap between application and the infrastructure.
Yeah, so I'll repeat the question in a second, but what you're describing is exactly the kind of full circle DevOps integrations that we see in really successful DevOps organizations. So the question was, when you have, a lot of the concepts that we just described specifically in the context of infrastructure make sense in the context of an application. An application requires that on whatever server it's running on, a particular firewall port be open, or that a particular service be available or running. And so does it make sense to actually bundle Puppet descriptions of those requirements into the application code base itself? And the answer is yes, it does make sense. And that basically allows, it's the tie-in, maybe the ops team culturally isn't ready for this, but if the company as a whole is amenable to that, the applications team can effectively be responsible for making sure that they define the requirements of their application as part of their own development process. And that Puppet code can be bundled into the app as opposed to into the overall infrastructure code base. remember that the end result of Puppet compilation, the manifests are not the end step. The manifests are just the beginning. The manifests are taken and compiled into a catalog, which is the actual configuration component. So if you have a separate set of manifests for the application and then another set of manifests for your infrastructure, those can be pulled up together into a single catalog that defines the overall, everything that the ops team and the dev team care about on the server. And this is also the point at which if the apps team has specified something that conflicts with the policy the ops team has set, that won't compile. You'll get an error, you'll get a conflict, and you have to take steps to resolve it at that point. All right. I think there's one more question. We're good? All right. Well, I think I'll go ahead and end there. I will be here for the rest of the day. If you'd like to talk to me, I'll just be out in the coffee area, except during the talks. I think I'd like to catch them. So thank you very much.